Alright, find the relative extrema of the following functions. F of x is 1/3 x cubed plus 7/2 x squared plus 6x plus 3. So step 1, let's find the domain. What are the three things you check for finding the domain? Log, fraction, radical. Are there any logs? Are there any radicals? Are there any fractions where there's a variable in the denominator? Because that's what I mean by fractions. No. So what's the domain? All reals. Yay. So we have nothing to worry about, which is nice. Step 2. This is where we do the critical numbers. Find any critical numbers. How do we find critical numbers? Very good. We find where the derivative is 0 and does not exist. So what's the derivative? Well, careful. It would be 3/3 x squared. Yep, so x squared. Good. So we're first going to see where the derivative is 0. How does x squared plus 7x plus 6 factor? X plus 1, x plus 6. Good. So setting each factor to 0, we get for x. Alright. And the other half is see where the derivative does not exist. So that's that domain thing again. Looking at the derivative, are there any fractions? Radicals? Logs? So the derivative always exists. So it never not exists. So our only critical numbers are -1 and -6. Is that okay? So step 3 would be draw a number line. And on this number line, we're going to just type in our, well, I'm writing. We're going to write in our critical numbers. Remember, go from left to right. And then we're going to pick some numbers in between the sections. Notice by putting the critical numbers on the number line, we've divided the number line into 3 sections. So I need a number to the left of -6. -7. Between -6 and -1. Careful. There it is. That's okay. Bigger than -1. We're going to put those 3 numbers in red there into your derivative. The reason we're putting into the derivative is because the derivative tells you the slope of the tangent line. And if we know the slopes of the tangent line around our critical numbers, we know about the increase, decrease. So this is where I said last week, if you want to make a table, put in your x squared plus 7x plus 6 into your y equals. Make a little table. You should get plus minus plus. Here we go. Here's the big conclusion. To the left of -6, it increased. To the right of -6, it decreased. So we went from increase to decrease. Increase to decrease. So what happens at -6? Relative max. Why? What did you say? I don't know what you said.
The negative, because it goes from positive to negative.
It goes from positive to negative, and
The domain.
there you go. Very good. So you have to check 2 things. There's a sign change, in this case positive, negative, and it's in the domain. If those 2 are true, then we have ourselves a relative max. Now, a relative maximum is a point. So we need an x and a y coordinate. We know the x coordinate is -6. How do we find the corresponding y coordinate? Plug it into the original function. So you're going to go back and you're going to find f of -6. So you go back to the original function when you need a y coordinate. 21? So the formal answer would be -6, 21 would be your relative maximum. And now we do the same thing around -1. To the left of -1, it decreases. To the right of -1, it increases. So we went from decrease to increase. So what happens at -1? Relative minimum. So the 2 reasons why: sign change And negative 1 is in the domain. Very good. But negative 1 is the x-coordinate. We need to find the y-coordinate, so we're going to plug in negative 1 back into the original function. You can go to math, convert to fraction to make a prettier fraction if it's an ugly number. It's 1/6. So negative 1, 1/6 is a relative minimum.